Hi, I'm David, and this is my YouTube channel, and I'm here today to talk about something very important in music called the circle of fifths. A lot of people are confused by this. They think it has a lot of data in it that they can't understand, and people don't understand key signatures and scales. And this is where it all comes home. This is where it all comes from. So I call it the secret sauce of music. If you understand the circle of fifths, you're going to be very much further ahead than you were before. Now, this is the circle of fifths, and yes, it looks a little busy, but we're going to break it down piece by piece as we go along, and here we go. What is the circle going to tell us? In other words, why are you watching this video? First of all, it'll explain to you why there are key signatures and what they mean and how they work. Secondly, it'll talk about the relationships of the major scale and the minor scale and how they work together and how they're related to each other. And finally, we'll see how that works with a little bit elementary chord theory about major and minor chords and seventh chords and how you can read off really important information right off the circle of fifths. It's very simple. Okay, the basics. We got to start from somewhere. The basic thing is the octave. An octave is a doubling of the frequency of a note. Now, every musical note is a vibrational pattern of a string or a dish or the bell of a trumpet or something like that. And it's measured in vibrations per second, which are called in the physics world hertz. And an octave is a doubling of frequencies. For example, the most common orchestral tuning note is a 220A. That is to say 220 cycles per second or hertz. Well, if you double that and go to 440, you have another A. If you go to 880, that's another A. If you cut it in half and go to 110, that's another A. What's the deal here? The deal is that the human ear hears these notes as sounding very, very similar. When you play two notes an octave apart, it sounds like you're kind of playing the same note with a little more flavor. Western music divides the octave into 12 parts. Now here I don't mean country western, you know, Gene Autry and the Sons of the Pioneers and stuff like that. I mean European music, dating back to Bach and the Baroque period and all that crap. The intervals are not numerically equal, but they're logarithmic, and that's because you've got this big gap where there's an A octave from A110 to A220 is only 110 cycles per second, but from A220 to A440 is 220 cycles per second. So you've got to figure out how do you scale that, and it's done logarithmically, and I won't go into that. That's in my book, and it's on Wikipedia and a lot of places. But for the musical purposes, think of them as 12 equal parts in any given octave. Now, the relative distances between any two notes in different octaves are the same. So if I have the distance from C to G in a lower octave and the distance between C to G in a higher octave, if I divide their relative frequencies, I'll get the same answer. And that's the key to music. These 12 notes are called in the musical parlance half steps. There's a historical reason for that. I won't go into that here. But a half step means a fret on the guitar or on the banjo or on a mandolin or anything that's fretted. It means the distance between any two adjacent keys, black or white, on a piano keyboard. For acoustic reasons having to do with the ratios of vibrations, there are 7 selected notes out of that 12. So in the key of C, it's C, D, E, F, G, A, B, C, right? And if you add a C on the top of that, as I just did, then there's 8 notes in all, hence the name octave. These are the white keys on the piano. I won't hide that from you. These are the ones that are very simple, and the reason the black keys are stuck off in the corners on piano keyboards is because old keyboards in the Middle Ages didn't have the black ones, it only had the white ones, and they had to figure out how to stick them in there. The basics of acoustics is that with any given note, there's a vibrational pattern. With any other note, there's a ratio between its cycles per second and the cycle per second of the other interval. Now, we're going to talk about intervals in a sense that it's always an ascending interval. It's not a descending interval. So every time I say two notes, the first one is the lower one, the second one's the higher one. If they don't have any difference between them, it's called unison. That's a 1-to-1 ratio, like an A on a guitar and an A on a mandolin playing the same frequency. That's unison. 2-to-1 is called an octave. That is to say, if one note is vibrating twice as fast as another. If one's vibrating 3 times every time another one vibrates 2 times, that's called a perfect fifth. 4-to-3 interval is a perfect fourth. Major third is 5-to-4. A minor third is 6-to-5. And these whole integer ratios were discovered by the ancient Greeks, by Pythagoras and his buddies. And they are exactly the same in every key. In other words, the frequencies aren't the same. The names of the notes aren't the same, but the relationship between the intervals is exactly the same in every key. And that's really the secret that's hidden behind the circle of fifths. The major scale, again, we're going to talk about the white keys, is often abstracted to use Roman numerals, where you'll have the root note, like in C, as Roman numeral 1 or I. The fourth note, Roman numeral F or IV, Roman numeral 4, which is IV. G is Roman numeral 5, and the next C on the top is Roman numeral 8, or VIII. These don't cover all the notes because you've got notes in between in some cases. And the pattern is 2-2-1, 2-2-2-1. You'll hear me say this a lot. So it's 2 frets, 2 frets, 1 fret, 2 frets, 2 frets, 2 frets, 1 fret. And again, every one of those intervals is a half step, and it's 1 fret on the guitar or mandolin. So if you're a fretted instrument player, think frets. The minor scale, in some cases, sounds kind of different. But if you think of the pattern 2-2-1, 2-2-2-1, not as a line, but as a circle. Here I put it out as kind of a clock. It's not a normal clock because it's only got 7 hours. But if you look at it, you have at 12 o'clock, you've got the major scale. Then you've got a gap of 2, and you've got a gap of 2, and a gap of 1, and a gap of 2, and a gap of 2, and a gap of 2, and a gap of 1. There's the pattern. But the minor scale pattern is 2-1, 2-2-1, 2-2. And the way you get that is by starting at a different place. So the secret here is it's the same pattern. It just starts someplace else in this endless loop. And I'll say this again later, but that's how I think of all this stuff as big circles. So keys are circles. Scales are circles. And the major scale is also known as the Ionian mode, and the minor scale is called the Aeolian mode, but I'm not going to talk about modes in this particular video. There are other minor scales, like the harmonic and melodic minors, but they don't reflect themselves in the key signature. You have to just know that certain modifications mean it's really the melodic minor, and most of the time they are not, they don't cover the entire song. They're parts of songs, so we don't go into that here. Where did we get the circle of fifths? Where we got it was that when you want to play the pattern 2-2-1, 2-2-2-1 in C, you can just play C, D, E, F, G, A, B, C, and there's no flats or sharps, and you can go make yourself a peanut butter sandwich. However, if you do the same pattern from G, you have to add a sharp. You have to go G, A, B, C, D, E, F sharp, G. What happens then? Well, now you know that if you're playing in G, every time you see an F, it better be played as F sharp, or you're not playing the major scale pattern. So the key signature for C is empty. There isn't one. There's no modifications necessary. It's white keys. If you're playing in G, you need a key signature of 1 sharp, that is F sharp, which is in different positions with the bass, with the treble and bass clefs, but it's still just 1 sharp. And the key signatures apply to all octaves. That means if you're playing in G, every F sharp in every octave and on every string must be sharpened, or you're not going to play the correct pattern. Let's take a quick look at the circle of fifths. It's a pie with 12 slices because there are 12 notes in the octave. It starts and ends on C, which doesn't need a key signature. So if you look at the C wedge, the one right there at 12 o'clock, you see C. Inside deeper, you see A minor, and above it, you see nothing. That's because there is no key signature. Now, if you go clockwise to G, you see that there's G, and then there's E minor, and then there's a key signature of 1 sharp. What do G and E minor have to do with each other? Well, they're the scales that share that key signature. C has the same key signature as A minor. How do you know the difference? Well, you have to look at the chords. If it's dominated by the A minor chord, and that's the most common resolution, is to go back to A minor, then it's in the minor scale. If it's mostly in C, but it has a few A minors here and there, it's probably in the C scale. Some songs come and go. One part of the song will be in the major, another in the minor, but they'll still be sharing that underlying scale pattern. Now, if we go to the left, counterclockwise, and remember we're still moving upward intervals, so we're going from C to F. To play the standard scale 2-2-1, 2-2-2-1, starting from F, you need to make all B's B flats. And its relative minor is D minor. And the key here is that the C and the C to G is a fifth, C to F is a fourth, but those intervals are reciprocal. Okay, if you remember from the pattern, from the thing before, there are some numeric things that happen in there, in the whole note ratios that I won't, frequency ratios that I won't get into. What it really means is that these two are reciprocal intervals. The fifth and the fourth reciprocate. And so you can think of it as a circle of fourths when you move clockwise and a circle of fourths when you go the other way. Now, we're going to get into some more stuff about these scales and chords. So your take-home message from this slide is each key has an associated minor key. It is the major scale pattern that you get when you start with that root note. And outside the circle are the relative key signatures for each key. So I just pretty much said all this stuff, and we're going to move on to the details of the circle of fifths. A deeper look. Every major scale is associated with a minor scale called the relative minor. And this is because this is the major and minor scales that when played share the same set of notes. They don't play them in the same order, but they play them around the circle, remember. And they use the same key signature. And remember too, if you're looking at C, if you go clockwise, you get G. If you go counterclockwise, you get F. And you should recognize C, F, and G as being the predominant go-to chords for any song written in C. But if you look at the minors, you see A minor, E minor, and D minor. Those are the go-to minors. These 6 chords predominate when you're playing and writing music using our system. So if you want to know what chords you're likely to run into in a song, find its tonic note. Let's say it's in E. And you look there and you see, well, the one ahead of it is B and the one behind it is A. So A, E, A, and B are the primary major chords. The minor chords are C sharp minor, F sharp minor, and G minor. And they bear exactly the same relationships to each other as the corresponding chords in C do. That's the big deal. All keys are created equal. At the end of the circle, it looks a little busy, and that's because the bottom 3 entries have 2 key signatures. Why? Well, because D flat and C sharp are the same note, as are G flat and F sharp, C flat and B. Let's forget about C flat and C sharp. You'll almost never see anything written in those keys because it's easier to write. If you want to write in C sharp, it's 7 sharps. But if you write in D flat, it's only 5 flats. I'd rather have 5 flats than 7 sharps. I don't know about you. Now, where it really joins up is down there at 6 o'clock. You get G flat and F sharp. G flat has 6 flats. F sharp has 6 sharps. In other words, by the time you get around there, you've pretty much sharpened and flattened everything, or flattened everything in the scale. And so that's where it starts to come back around the other side. So again, the circle of fifths is the list of key signatures, and these are the ones that arise, and it's just basically a shorthand. You don't have to say, oh, I'm playing an E flat, therefore the notes are E flat, F, G, A flat. No, you don't have to do that. You just look right on there, and you can read off your primary major chords, your primary minor chords, and then you can start to jazz it up. Let's talk a little about chord theory and how this works. A chord is a set of at least 3 notes. And a major chord has, I should back up, they each have 2 intervals. That is to say, with 3 notes, you have 2 intervals. The interval between the first 2 notes, the interval between the second note and the third note. A major chord has a major third, which is 4 half steps or frets, followed by a minor third, which is 3 half steps or frets. A minor chord is the opposite. You just turn it upside down. The first interval is a minor third. The second interval is a major third. So let's take an example. C. What is a major third up from C? It's E. And what is a minor third up from E? It's G. So the notes in a C major chord are C, E, G. Let's do minor. You start with C. What is a minor third from C up is E flat. A major third is from E flat is G. C, E flat, G. That is a C minor triad. So you can work all this stuff out pretty simply but we'll talk about the bottom line, which is really cool. If you think of every key in Roman numerals, and we don't have to do that all the time, but we can take a simple example here with C, where C is the 1, F is the 4, and G is the 5. It turns out that these are the only major and minor chords that you can actually play in the key of C without introducing an accidental you shouldn't have. In other words, if you're playing just the white key notes, no sharps and flats, these chords are all playable given just notes in the key of C. But they're the only ones. There's no other major chord you can play. You can try it. It won't work. The same thing with the minor chords. You can play A minor, D minor, E minor all day long in the key of C. No other minor of all 12 of them will play in the key of C without you're introducing a sharp or a flat, or several of them. Now, that's why these wedges are so important, because right there, if I look at C and I look to the left and I see the F, and the right and see the G, I'm getting the key signature, which is right over the C. I'm getting the 6 chords that I'm allowed to make that are major and minor in that key, and those are really important. There's one important additional chord I want to introduce you to, and that's called the 7th chord. Some people call it the dominant 7th chord to distinguish it from the major 7th chord. And that is a 4-note chord. It's got 3 intervals, and it has the 1, the 3, the 5, and the flat 7, not the major 7. That's a major 7 chord. And if you look at that and you make out the notes, you'll recognize when you play that. If you try to take that pattern of notes, 1, 3, 5, flat 7, and you try to play every possibility in the 12 in the key of C, the only chord that actually lives within the white keys is G7. And because the 5th is also known as the dominant, this is called the dominant 7th chord. So one other chord that is allowed, that is perfectly acceptable given the key signature, is the 5-7 chord, which in C is G7. Now, in my book, which is available on Kindle, I talk about the magic 9, but so far we only have talked about 6, 3 majors and 3 minors. The other 3 chords are 7ths, and they arise from making 7ths out of the minors. So in C, that would be changing an A minor to an A7, changing a D minor to a D7, and changing an E minor to an E7. Now, those chords have notes that are not in the key of C, but they have very good color, and they make nice songs, and a lot of country music and a lot of rock and roll, and quite a bit of jazz, especially early in the 20th century, use these chords to death. You can try them out for yourself and see how much color change it makes in your music. Okay, we're going to review what's been said. The take-home points are the octave has 12 notes. Of those, 7 notes are chosen as a major scale pattern, and it can start anywhere. And the pattern is 2-2-1, 2-2-2-1. A key signature is the set of sharps or flats that's necessary to play that pattern from whatever starting point you want to start on. And you use those sharps and flats in every single octave, on every single string. You must sharpen all of them or flatten all of them, or you will not be playing in that key. If you look at the circle of fifths, find your key, and then look to the left and right, and you will find your subdominant, which is the 4 chord, your dominant, which is the 5 chord, and you will also find the 3 associated minor chords. Those are the 6 chords that are 99 times out of 100 going to be the next chord you're going to go to. It's going to be one of those chords. And the relative minor scale is a little different than the pattern, but it has the same structure as the major scale pattern. You just start at a different point if you treat the scale pattern as a circle. Finally, why do we have all these keys? Why don't we do everything in C? It's easy, it's white keys, blah, blah, blah. Well, first of all, you choose it most of the time for the range of a vocalist, right? There are, we all know about sopranos, altos, tenors, and basses, and typically those voices are separated by about a minor third to a fifth from each other. Women's and men's voices are about a sixth apart, and basses and baritones and tenors tend to be about a third or a fourth apart in their ability to reach notes. Another is the ease of playing. If I sit down with a guitar player who's not all that with it, and he wants to, plunk, I'll say, let's play in G, or let's play in D, or let's play in C, because I'm pretty sure he'll know those chords. but I don't think he'd be able to do too well in A flat. Remember, the big thing I'm trying to convey here is that all keys are created equal. All of that key signature stuff and sharps and flats and the different names for things all hide the fact that the relationships are exactly the same. And this is what they do at Nashville when they have playbooks that just have Roman numerals, where they can sit down and a singer says, well, I know normally we do Misty in E flat, but I want to do Misty in F. A jazz player or a horn player looking at his sheet music go, oh my God, I can't do that. Well, if you're a guitar player and you've got it down in Roman numerals and you know your Roman numerals in different keys, you can just say, fine, I'm going to go get another beer. This is going to be a piece of cake. And finally, the Western music system, that is to say music from Europe and related countries, guarantees that any relationship you find in a key, whether it's an interval or a chord or a scale, is exactly the same in every other key.